we're going to be talking about diagramming or describing and documenting your architecture. Fantastic. Okay, so a curious question here. How often has this happened to you, where you're the architect and you say, I've finished creating the architecture for the new system, and all your stakeholders say, that's fantastic, great, let's see your solution. And what do? You say, here it is, there's my solution. And all of a sudden, these stakeholders say, wait a minute, what is this? I mean, can't you describe your architecture solution in a way I can understand it? And of course, as the architect, it's like, I did. That is my architecture. I gave you the diagram for it. And the whole world basically comes crumbling down. And this is the point where these two parties, the architects and any kind of stakeholders, just kind of stop talking to each other. Yes. Yikes. You know, we create architectural solutions to fairly complex business problems. But one of the challenges we face as a software architect is how do we convey that architecture to developers, to any kind of business stakeholder or product owner? Maybe it's a key business sponsor. That's what we're going to look at in today's session. So how do we effectively communicate our architecture solution? Turns out, one effective way I have found for doing this is something called an architecture narrative. In other words, what we do is we create a compelling story about our architecture. It's kind of an interesting concept, isn't it? Because when we look at what is included within our story of our architecture, we see that it has a lot of different ingredients. I suppose we should talk about our architecture diagrams. I mean, that's generally what we as architects consider our architecture solution. Look, here it is. I've got all these diagrams to show you. But there's other ingredients that go into the mix in our story that we're going to tell in the next 60 minutes. Also, maybe I made a lot of architecture decisions. I should probably include those as well. I thought about a lot of alternatives. Do you know about those? No? I should probably include those in my story, as well as all the trade-off analysis I did, constraints that I was faced with, maybe some business problem context, and also, what were the driving characteristics, and finally, some unique challenges that we faced when I created this architecture solution. And these are all the ingredients. Now, if we just kind of threw these into a pot, it wouldn't tell a very compelling story. It would be a very confusing story. So what we're going to do in this session is see some techniques that you can actually just start using tomorrow. Well, tomorrow's Saturday. How about using Monday, unless you have to work tomorrow, to organize these different ingredients that tell a compelling story. This is one of my favorite books, Shadow of the Wind by Carlos Ruiz Zafón. It is an amazing book. It is on my top 5 list, and I'm pretty old. I'm not quite back where the dinosaurs were, but it's sort of there. I've written a lot of books. I've read hundreds and hundreds of books, really good books. This one's on the top 5 list. Why? Because it was a compelling story. It was an amazing story that captured me, every single page of this book. Why can't we do the same things with our architecture solution? When people read your documents, look at your diagrams, no, it's kind of boring. I'm going to show you how to make it a compelling story. Now, in order to build a story, a description of our architecture, necessarily it involves something called a narrative arc. When we write books, novels, technical books, we use something called a narrative arc. Now, a narrative arc is a way of describing your story. Most good, compelling stories and movies going to follow this. Or maybe it's that you're just meeting a friend after work, and your friend says, "Oh, listen, have I got a great story to tell you?" They're probably going to use a narrative arc. They're not going to start with the punchline and then say, "Now, let me tell you how I got there." That would be a little weird. No. We start with an introduction and exposition. Stories start providing the context. Who are the characters? What's the setting? Then, as time goes on, tension increases. And you can see about in the middle of this arc is where we start getting some complication. The story gets really interesting. Things are happening. People die. Hopefully not in our architectures. And then, finally, we get to the climax of the story. But boom, the hero saves the day and the resolution, and then the story closes. It's called a narrative arc, and this is what we're going to focus on to tell our architecture story. Now, on top of the narrative arc, which was a literary term, is something called a three-act structure. And this is the way movies, books, our architecture descriptions are all well-formed. And so if we overlay the three-act structure, Act 1 is the setup of our story. It introduces the characters. What's this kind of story about? I want to make it interesting at the start. Then we have Act 2. Act 2 is the confrontation. That's where things get a little challenging. The story gets very interesting. We have a lot of conflict. And finally, we have Act 3, which is the resolution of our story. What we're going to do in this session is leverage the narrative arc along with this three-act structure so that I can show you how to effectively describe and present your architecture. You know, if you've ever thought about it, you spend a lot of time creating an architecture for your existing system, or maybe it's a new system. Where is all that stuff? It's spread probably everywhere. I mean, you've got diagrams over here. Maybe there's a couple of Word documents. We've got some ADRs over here somewhere. Maybe some ADL from yesterday. But the point is it in a cohesive package? That's what I want to show you. So let's build our architecture story, our architecture package, which will make it compelling for somebody to actually read and understand our architecture. Handhold and guide them through my solution and how I came up with it. So let's all start this with the Act 1, and that's the setup. What does this actually include? When we talk about Act 1 from our architecture description, what we're really talking about is, why are you reading this architecture documentation and diagram? In other words, what we're describing is, what is the business problem we're trying to solve? What's the context of the problem? You know, so many times, somebody might read my architecture and really not understand the context of the business problem that it's in. Also, what we include in here is, why is the business doing this? That's probably good to know if I'm looking at your architecture or somebody else is looking at yours. And also, who are the major players? This is the setup. This is the start of our story. And so let's take a look at all of these ingredients, because what is included in this part of our story is the business problem. This is a necessary attachment to describing my architecture. Does everybody understand all of the business problem and why the business is doing it? That provides me context for my story. And so we might have situations like this, where all the business stakeholders or even the developers, which are stakeholders in our architecture, say, you know, I wish we had a better understanding of the overall picture of what we're building here. How many times have we just thrown architecture diagrams without really showing a context of it? It's that simple. For example, here's a context diagram for a ghost kitchen. Now, a ghost kitchen is where we have a kitchen way back in some building somewhere. No one sees it. That's why it's a ghost kitchen. And they're preparing food, and they make it available to people. And so consequently, that ghost kitchen prepares food. They have people deliver it to either cafes for point of sale or either smart fridges. where you can go up to a smart fridge, run a card through, and actually get your meal. That's what we're building. Look at how simple that is. And all of a sudden, all of us in our story say, I see what we're doing here. Okay, thank you. These can be that simple. It could be an architecture diagram that looks like this, a context diagram, similar to the C4 model, where there's our system, and here's all the things that are going to interact with it. This provides us a context before we start diving into your solution. Maybe it's a student standardized testing system, where students are taking a same standardized test in every single grade. And so the students get a question, they answer it, they get another question delivered to them on the screen. Meanwhile, we auto-grade that true, false, or multiple choice and store it in a database. Folks, that's what we're building. This would take maybe 10 minutes to draw and diagram, but it provides us a context, a roadmap for actually what we're building. Let me show you one more, a customer trouble ticket system, where customers who buy our equipment can enter a ticket into the website. When they create a ticket, we assign experts in the field that go to the home or office. We notify the customer. We upload the ticket to the expert's mobile device. They head off to the home or office, fix it, mark it as complete, and then the customer gets sent a survey. That's our ticket system. And so these are examples of ways of providing, on the very start of our story, of our architecture, a business context. But then there's part two of that business context. Why? Because I spent a lot of time on this architecture, and one particular stakeholder says, this is a waste of time. I really don't see why we need to replace our existing order entry system. It seems like it's perfectly fine to me. How compelled are they to read your story? How compelled is this stakeholder going to be to pay attention to your diagrams? Not very. So we provide a context, but also a justification. Why are we doing this? This points to our second law of software architecture from our book, The Fundamentals of Software Architecture. Why in architecture is more important than how. So there's a couple of interesting things when we talk about the why piece. This is the version 1 of the Zachman framework. And this is a taxonomy that's used in enterprise architecture for really describing a solution. I used it a lot in the past. I use it every day now. But I don't use the whole thing. I use the why models. That's what I leverage, because there's a rationale at every level here. At an executive perspective, the rationale for all of the important business goals and strategies, that's describing really why we're doing this. At the business segment level, how is this benefiting the business? Here's where we are, folks, at the architecture perspective, which basically are our assertions and justifications for our architecture decisions. At the engineering level, this is from an application standpoint, those capabilities. Can we justify the fact that we do need to scale? And also, finally, the technical perspective on the technical infrastructure choices we make. I leverage this model every product and project I work on. That's how important the why is. If you're going to read my architecture diagram, which we will in a little bit, don't you want to know why we're doing this? Providing that additional context. Let me show you an example of why this is so important. So in a typical organization here in the basement, we have operations. Barely above them are the developers. And then on top of the developers, we have all the architects. As we keep going up the chain, we have business and finally the executive level. Well, here's the problem. So operations says, I know we're told to move to the cloud, but why are we moving operations to the cloud? I mean, they don't know. They don't have a context. So what do? They ask the developers, hey, why are we? Oh, the developers say, hey, that's a good question. The reason is because we're developing new cloud-native applications. Duh. A cloud-native application needs to go in the cloud. Oh, says operations. Operations is happy. But then the developers stop and say, wait a minute. Why are we developing new cloud-based applications, cloud-native applications? They don't know. That'd be nice to know. So what do? They ask the architects. And the architects say, well, because we're moving all of our customer-facing apps to microservices. Oh, got it. Microservices are cloud-native apps that need to go in the cloud. Hey, fine, thank you so much. The developers are all happy, and so they're all working. Then the architect says, wait a minute. Why are we moving all of our customer-facing apps to microservices? So what do? They ask the business, our business sponsors and stakeholders, and they say, well, because we need to add new products and features quickly. Microservices gives us that agility. Duh, I forgot about that. Yes, thank you. Now the architects are happy. Then, finally, the business says, wait a minute. They ask the executive, wait, why are we adding new products and features quickly? And it goes all the way up to the highest level, and the executive says, oh, because we want to become the #1 online insurance provider in the nation. Oh, says everyone. The why is so important. This is really described in Gregor Hope's book, The Architect's Elevator, an amazing book about communication at all the levels. But here, we're making it very concise just to illustrate that what we're really after, everybody, when we want to ask that why, describe our problem as a why, is to get to that highest level. Not that just we're building microservices, but keep being that annoying 3-year-old. And I'm sure some of you have kids. I remember as an annoying 3-year-old, why, Daddy? Why is the sky blue? Well, it's a reflection off the sun due to dust particles. Why? Well, because the sun orbits, the Earth orbits the sun. Why, Daddy? Well, just stop asking me questions. I mean, you want to be that annoying 3-year-old to continue to ask why, until you get to that top position of understanding really the context. Now, there's a lot of reasons why the business may want your architecture. Oh, it might be because they're migrating to a new platform because the vendor's not supporting our old one. You're right. This order entry system is fine, but it's not a waste of time because it's no longer supported. Let me see your architecture. Now we know why. Maybe it's just because business changes, and all of a sudden, regardless of how much we change our processes, changes in the old system just take too long. And we're in a highly competitive market. We need a more system. We need a new system. We can't just keep repairing this old one. These are reasons. Okay, so the last thing that happens in the setup are the characters. If you're going to read a book or watch a movie, what happens in the opening scene? You see usually the main character, or at least some of the characters that are going to be involved in your story. Who are the characters in your architectural solution? Because it's interesting, if we look at that ghost kitchen, the players, the characters in our movie, our film, our book, our architecture happen to be the ghost kitchen. That's obviously a participant, a player. The delivery people are a player, and they're going to be involved in my solution. Also, the smart fridge, the cafe with the POS system, and also all of our customers. And so we start identifying who are the players, who's involved in this. And also, as a matter of fact, it's not just all about the solution, because it may involve, for example, what development team or teams are going to be involved in implementing this architecture or are currently maintaining this architecture. What about the project sponsor or the business stakeholders? There might be a product owner involved. It'd be nice to know who that is for our architecture. If we don't know, when we find out, we update our story. It could be internal users, operations support, even an architecture review board. These are all players in our story. And they might have some influence in how I formed my architecture solution. All right, that's Act 1, introduction and exposition. I'm going to describe my architecture to you, but before we get to all the diagrams, it's important to know who the players in the context are of our story, the narrative arc. I'm walking you through our story. Now, let's look at perhaps the most interesting part of our story. Any part of the story is great. But can you imagine, though, if we take Shadow of the Wind, one of my favorite books, and just randomly open it up towards the middle and start reading? You think this book's going to be any good? Of course not. And that's what we do as architects, unfortunately, all the time. When I'm describing my solution to somebody, I'm having them open the middle of the book. But now we're in the middle of the book. So we start with that step one, or act one, the setup. Let's look at confrontation. There's a lot of things that go into confrontation because what we're really looking to address here in our architectural solution, not our diagram, but our solution that we came up with are, first of all, what are the conditions and constraints? I'm going to show you an architecture diagram. You're going to try to understand my architecture. Wouldn't it be nice to know my thought process? Wouldn't it be nice to know some of the constraints and conditions that I was faced with? That would, wouldn't it? It gives you additional technical context. So what are the technical and business constraints in my story? What architecture characteristics do I have to support? Talk about confrontation and challenge. Yeah, but this is a great place to describe these because these are constraints. Also, what are some of the unique challenges that I faced with this business problem in the forming of my solution? And finally, what are the alternatives and corresponding trade-offs associated with this? You see, what I want to do here when we tell our story is be able to give you, the reader, my thought process. I want to be able to give you, the reader, the experience that I had to go through in forming my architectural solution, so that when you're reading that architecture, you're understanding the constraints and the conditions that we faced in creating this solution. So let's take a look at these, because what the ingredients are in this area of our story are all the constraints, all the unique challenges, driving characteristics, alternatives, and trade-offs. This is where we describe these things in our story. So let's talk about these constraints. Constraints are key. They are necessary to build an architecture. Has anybody heard of the Chandler Project? Is anybody familiar with this great architecture story every architect should know? It's called the Chandler Project. This is a real story about a company who has a whole bunch of architects and developers and said, here, build me a solution. Well, what's our constraints? None. How about a timeline? However long it takes. Do we have a budget? Nope. Infinite budget, infinite timeline. And guess what? It failed miserably. We have to have constraints. Those constraints are what shape our architecture. Let me give you examples of what I'm talking about here. So here's an example of a confrontation. This is my current thinking of our architecture solution for the ghost kitchen. However, we start getting constraints. We currently deliver 400 meals a week, but what the business wants is between 1,500 and 2,000 by the end of the year. 6 to 8 additional locations next year, but we have low setup costs. Those, folks, are examples of constraints. I list those in my architecture story, in my solution. Because did you notice what happened? My architecture no longer fits within those constraints. So now I start modifying my architectural solution to accommodate those constraints. Oh, but there's other kinds of constraints that may be technical. Chef Tech, which we're using. Unfortunately, it's used for restaurant inventory management. Toast, we're going to use for point-of-sale solutions. Intuit, QuickBooks for accounting. These are all tools that we're forced to use. Those are constraints. And all of a sudden now, my box that I'm able to build this architecture in, as you'll notice, is getting smaller and smaller. So we outlined both those business and technical constraints that we're really faced with in forming this solution. You will, I guarantee you will get questions. I don't understand why you did things this way. I don't understand why we're using async over to the restaurant inventory management. I don't get why you're doing these things. It's because of our constraints. So these come as part of our documentation, our story. Now let's talk about unique challenges, because a lot of times we're faced with some challenges that, quite frankly, cause us to, well, sometimes start over. So we're almost there. We're almost at the top of the cliff in terms of our architecture solution. I think we got it this time. And all of a sudden, we're faced with some pretty serious challenges, which we document as part of our solution. So, everybody uses a smartphone to order the food from the ghost kitchen. Many low-income families in a lot of countries might not have access to a computer or a smartphone. Oh, and that's why this system exists. Oops! And it starts bringing us further away from our architecture solution. We may have other kinds of challenges. What if the kitchen runs out of food or certain items? Oh, didn't think about that. All of a sudden, we get further and further away from our architecture. Maybe it's something about the kitchen may run behind. They're not able to fulfill these requests, and people are waiting for this food that they ordered. And that brings us even further away from our solution. Man, we were almost at the top of this rock wall. Things like this. Oh, by the way, we just looked. Chef Tech doesn't have third-party access to their API. What? We have to integrate with Chef Tech? Yeah, you have to go through the web. Wait, there's no API interface? Nope. That brings us even further away. These are some unique challenges that we face when forming our solution. These are the things we document. These are the things that are part of our architectural solution. And of course, this is where we put our driving characteristics, our architectural characteristics, the ilities, all of our capabilities right here. And we ask, what are the critical and important characteristics we need to support here? Boy, talk about confrontation. Talk about conflict. But we ask, what are the scope of these characteristics? Can we justify them? We're saying all this stuff about the fact that we need scalability. Where's that coming from? The fact that you're mentioning performance here, where did you get that? And so we tie them back to those specific business requirements. This is a critical part of our architecture story, and because it gives us our alternatives, because we know performance and scalability are really key in this system. We go to our star chart rating from our fundamentals, by the way, which you can download. I'll show you the link in a little bit, but you can download from my website, developer2architect.com/resources, and it's right there, and you can download this star chart here. But clearly here, we have 5 stars, and event-driven and also space-based. Wow, so those are probably good options. Now I'm starting to derive in my story, hey, there's a lot of conflict. I see a lot of challenges here. I see the players, but now I'm starting to see your thought process about what were some of the alternatives that you did. And speaking of those alternatives, what were the corresponding trade-offs of those as well? Because we may form certain ideas, but then there's trade-offs because other solutions might be a little bit better. And this involves, during our story, to undergo something called modern trade-off analysis, something that was paramount as a theme. As a matter of fact, it was our narrative arc of our book, Software Architecture, The Hard Parts. That was our story that we told. Every chapter had trade-offs. Every chapter in that book, we showed techniques, and we showed the trade-offs. So let's undergo modern trade-off analysis. I make a lot of decisions. How did I make those decisions? Well, it kind of stemmed originally from our business requirements, step 1, or I should say not step 1, act 1, our setup, the business drivers. Time to market is one of the main paramount things we need. So in this part of the story, I use my architecture translation engine, my brain, to say, well, what architectural characteristics then support time to market? Oh, maintainability, testability, and deployability. All 3 of these are driving critical characteristics for our architecture. Why? How do I tie those back? Because these all support time to market. Maintainability is the ease in which you can find code or find where to place your code as you're writing it. That's maintainability, knowing the code base, knowing where to go immediately if a problem happens. Testability. Testability is 2 things. It's about the ease of testing and the completeness of testing. There's certain architectures that don't have good testability. I will say any sort of monolith falls into this category. Now, you might say, Mark, nope, you're completely wrong. Nope, we have a modular monolith. And as a matter of fact, you're very wrong, because the ease of testing and completeness is great. As a matter of fact, we have over 12,000 unit test cases in our test suite. Ha, got you there. Really? Let me ask you a question. How long does it take you to execute your test suite? Minutes? Hours? Days? Let me ask you a second question. So this is actually a real scenario. So I'm typing away, or you're typing away. And what you're doing, you need to make a change in the system, the monolith. Now, all you're doing is changing the text of an error message. That's all you're doing. We had a misspelling in the text of an error message. That's all I changed. Okay. But, I know I didn't break the system, so I, as the developer, I run the test suite. And 200 tests fail. I changed an error message, so I know it wasn't me. What would you do as a developer at that point? Oh dear. Well, I guess I could take my little 5-minute task and I can find out what all those errors are, and after a couple of days, I can repair them all. I could do that. I could spend a half a day running around finding out who caused the error to happen and tell you, hey, fix that, fix this error. Did you not even run the suite? You've got all these errors. I suppose a third thing I can do is just assert, parens, true. Just comment out all those 200 tests. Now it's passing. What would you do? I would do number 4. I back out my change and wait until the full regression passes. By the way, which it never will. Yeah, tell me that's testability. When you make a change in a large monolith, what do you test? I test my change. Did you test anything else? That's what the completeness of testing is all about. But if we go to the opposite end, microservices, I need to make a change. I make the change in a single deployable service. It's fine-grained, single purpose. What's my testability? The ease, type, enter. The completeness, I've got 23 tests to run for that particular microservice. 100% coverage. Did I impact anything else? No. That's testability. And finally, deployability. Oh, and by the way, if you don't believe me, what is the very fastest way to time to market? Time to market, or speed to market, is how fast, once I apply that change, that customer gets it. What is the very fastest way possible of getting it to the customer? Don't test. Just don't test, because our testing cycle takes too long. It takes weeks. The product owner insists and the business owners insist on doing full scenario testing for 2 days. That's not time to market, folks. And finally, deployability is about 3 things. It's about the ease of deployment. It's about the frequency of deployment. And it's about the risk involved with deploying our software. Now, we're faced with a decision. I don't know. Should this service be a single service, or should it be 3? I don't know. I hate making decisions. You know what's funny? As an architect, and once you become an effective architect and make decisions and trade-off analysis, here's what will happen to you. You drive to the market and you see 10 parking spots available, and you just sit there. People are honking at you, and you're sitting there. Why? Well, I could park there, but then that's kind of close to that other car. I could park over here, but then I'd have to walk a little further. And all of a sudden, you find that your daily tasks are all full of trade-off analysis, and nothing ever gets done. Yes, so I'm like, another decision to make. Well, I boil it down to 2 things. A single service, things are going to be a lot faster. But if I break it apart, it's going to be a lot more maintainable. Well, we all go for performance, don't we? Yes, premature optimization of performance. But now what we do is we say, how do I make this decision? I tie it back to our architecture characteristics. Which one of these satisfies our drivers? Certainly not performance, because maintainability is even there. And then I tie this decision back to the business case, time to market. Which one of these two things is going to solve or serve the business more? Performance or maintainability? The answer is maintainability, because that gives us time to market. That's what's important to the business, not responsiveness. No. And so now I tie it back to the business drivers, and guess what? There's my decision. I don't have to spend days on this. Yeah, I make my decisions. Modern trade-off analysis leverages these 3 steps to quickly and effectively not only make a decision, but justify our decision. Now, here is a sheet that I use at work all the time, and I have for quite some time. And as a matter of fact, this is located in my resources as well. If you just go to my website on the menu, click resources, you can download this in PDF, PowerPoint, Keynote, and Word format. But it allows us to list as part of our story, our documentation of our architecture, as I'm describing it to you, all of our driving characteristics, what were the top 3. And accordingly, you'll also see lesson 112 in my lessons. So that's number 112. Just as a short 10-minute video on just how to use this form and kind of the dynamics of it, and use it as a vehicle for negotiation and collaboration with the business. It's 3 pages long. The first page is the actual form. The second and third, I just offered up my definitions for all of the common architecture characteristics. I would encourage you to add your own context definition of these. Anyways, take it, use it, modify it, but please use it. It's a great way of recording these. And that brings us in our story to Act 3, resolution. Think about where we're at with the story right now. I've introduced the characters. I've described all of our constraints, challenges, trade-offs, the alternatives I've thought about. You know what you've just had through this story I told you so far? My experience, my thought process, what went in to the resolution. Because right here in Act 3, what we're describing is our solution now. Oh, finally we get to the diagrams. Oh my. So we're saying, hey, what is my proposed solution here? This is where I put all the diagrams, the sequence diagrams, any kind of context diagrams. Now, finally, we get to the part about diagrams. But also, what were my major architecture decisions I made? This is the place in the resolution where I describe all those decisions. And finally, what were the risks, or what are the risks associated with my solution that I'm showing you? These are the all 4 things. I want to start with the decisions, because this is where I usually start my story. Before I'm going to throw a diagram at you, I'm going to describe for you my decisions I made as an architect and the justifications for those. And for this, I usually leverage architecture decision records. Now, you might say, oh yeah, I've heard of these things. Our company doesn't use them. Well, company I'm working with right now doesn't either. But I do. I do, because it's part of my architecture story. It's part of my solution. It's an artifact that I find very useful. So even if your company doesn't use them, doesn't mean you can't use them. So an architecture decision record, every decision I make is a separate document or a separate page in a wiki. The title shows what that decision actually was. The status is either proposed, accepted, or superseded. The context is where I describe a short 1 or 2 sentence description of what is forcing me to make this decision. What's the situation here? Oh, I have to transfer data over to Michael. That's 1 sentence, everybody. I have to transfer data to Michael. What are my alternatives? Well, I could do this either synchronous through a RESTful call or async through a message queue. That's pretty cool. 2 sentences, folks. That's it. And now I have a context for that decision. Now, the decision is the justification. Here's my decision. Here's why I chose to use async with Michael. And in the consequences section, this is where I usually outline the trade-offs that I was both communicating with the stakeholder or arguing with myself. And that's what an ADR is. I have an idea. Let me show you an example of one. So here's an actual architecture decision I had to make. So we've got internal, external, and B2B clients. they all come in to an Azure service bus. Now, it's a single bus. Now, we've got a back-end customer system. It's pretty old, and it doesn't even know what the web is. So it communicates to the rest of the world through RabbitMQ. Now, a decision was made and approved that we're going to federate that Azure service bus, or that hub. So in other words, we're going to have a specific hub for internal, external, and our B2B clients. We did this because of certain service level agreements and service level objectives that we weren't meeting with that single hub. Because sometimes we brought it down and some of our B2B clients were still operational. Oops, sorry. So consequently, we have an architecture decision to make. Or I should say, you have an architecture decision to make. Well, I could create dedicated RabbitMQ clustered instances for each of those hubs. So in other words, each hub has a corresponding RabbitMQ cluster to match that SLA. And all three of those then communicate with that back-end customer-facing or customer system. Or I could just use a centralized broker. Nice. Which one should we use? What would you do? This is a typical decision an architect makes. You know what the first thing I see here, folks? I see a single point of failure. What's the purpose in separating all these hubs if we're still going to a central point? Yeah, this is a performance bottleneck. This is a single point of failure. Don't do this. Oh, you're right, Mark. You know what? Okay, cool. Let's stick with the dedicated broker instances. Let's do that instead, because now each of those meet the SLAs. Oh yeah, how much is that going to cost us? Probably quite a bit. Also, you know what we have to do? We got to modify that back-end legacy system, because now it has to communicate with 3 different brokers. It has to connect to 3 brokers, not just one. That means we have to modify our code. We have to modify that system and retest that thing. Oh, yeah, that's going to take months based on the size of that legacy system, that CRM. Yikes. You know what? You're right, Mark. We better go to option 2 right here, centralized broker. Oh, yeah? Well, what about that performance bottleneck? What if that thing goes down? All right, so let's make a decision. ADR 21, centralized message broker for the gateway hub. Wow, Mark went centralized. Well, I accepted this, so this is already accepted. Well, let's look at an example of the context. This is an example of an ADR. Okay, let's read this. The incoming gateway hub is federated into 3 separate hubs, period. Okay, there's a statement of fact. So we have 3 hubs. Access to the customer information functionality is only through AMQP using RabbitMQ, period. Okay, there's my context. Well, what are my options? Well, I can use a centralized broker or a dedicated broker instances for each of the hubs. That's an example of what we write in the context of an architecture decision record. We're not documenting the world. 1 or 2 sentences. I don't need to outline page after page these 2 alternatives. What I need to do is justify why I chose one of them. So, here's my decision. We will use a centralized message broker for all instances. Notice this grammar. How many times have you heard an architect say, or you have said, you know, I think a centralized broker would be best? That's great, what you think, Mark, but what's your decision? You see, all too often we use this little passive kind of grammar. You know, this one's probably best. Okay, but what's your decision? This comes from Michael Nygaard, kind of coined ADRs back in 2011. We will use this. I may not even like it. I may not agree with it. I think the other solution's better, but we will use this. And so that's why that grammar's that way. I disagree with you, Mark. We're going to have a performance bottleneck. But wait a minute. We currently have low request volumes. And notice in this ADR, I specified, what do you mean low? 200 requests a second. That's nothing. That is literally nothing. And we don't expect this to increase in the foreseeable future. Therefore, we do not see a performance bottleneck issue. Oh, yeah, but you still, okay, all right, yeah, okay. Yeah, I see what you mean. You still have a single point of failure, though. Oh, really? Because you know what we're going to use in this centralized broker is we're going to leverage the RabbitMQ failover protocol and clustered RabbitMQ instances to address those single point of failure. Oh, yeah, so, yeah, that's pretty stable. I mean, RabbitMQ is built on the Telcom platform in Erlang. This thing's hard to kill. Also, we don't have to change the application. Right now, the application, this legacy system that's really complex, only has one connection to a broker. It only has one connection to the broker. And consequently, the other aspect of my justification is that, if you change your mind and collapse two of these hubs, go do it. There's no changes to systems. We don't have to retest anything. It's all infrastructure. Effectively, with this decision, what I've done is I've separated infrastructure from our functionality. Expand all you want. Oh, we're going to add a fourth hub. Okay, go ahead. I don't care. It makes no difference to me. And there's always consequences. We're going to need high availability servers. All right. So what we do with these ADRs is we may write an ADR, an architecture decision, for one very small piece of the system. We're going to use centralized customer notification. That's an architecture decision. We're not going to have a separate service for each type of notification we're sending. We're going to do all centralized. So all customer notification that we do comes from one specific place in this system. That's a good example of that scoping at that minute level. But we may have an architecture decision that impacts a whole domain of the system, or even the entire system itself. We will use the microservices architecture style for this system. There's a good example of one that impacts the entire system. Okay. Now, we finally get to the fun part, diagrams. All right. So what I want to do is this, 70. Here we go. Okay, let's talk about architecture diagrams. This is one of the ways, in the typical ways, we convey our solution. But do you see in our journey so far, in our story, this is only one small piece, isn't it? Yeah, it's a pretty major piece, but it's only one piece of our story. So let me show you some diagramming tips, because this is the architecture for our system. What do you think? You like it? Approve? You are the architecture review board. What do you think? First of all, what is it, Mark? Okay, fine. Let's actually take a look at some tips for diagramming. Whoops, and I forgot to hit enter here. There we go. Okay. So first thing is, it's missing a title. Duh. The title gives it a context. I don't even know what I'm looking at here. Oh yeah, this is our trading platform, and it depicts the major information flows between all of the services. Oh, thank you. Yes, if there's a sequence you want your reader of your story to go through, then number these 2.1, 2.2, 2.3 to help handhold and guide that reader through the story. Okay. So next thing are lines. Every architect I know struggles with lines. Yes, and so the first part is this. I have no idea. You're saying these are the major information flows, and you're just showing lines. So add a description to the line. It provides that line context. Oh, that's probably a good idea. Oh, so transactions go back and forth between RKS and PM. Trades go to ATP. Also, trades go to RT and CE, and ratings go to SRS. That really helps me. The other thing is to favor unidirectional lines. Why do we do bidirectional lines as architects? Because we're told to put arrows on them. I don't know. I just want to get this thing done. They convey no information whatsoever. So unidirectional lines show the direction of information flow. That's what they do. For example, RKS sends trades to PM. Look at the understanding we're gaining of the how this works. Also, PM and ATP, yeah, but those do have trades going back and forth. Ratings. Now, here's a complexity when it comes to lines. This is showing information flow. And typically when you show information flow, what you show is sender to receiver of that information. But what's the problem? If I did an arrow from SRS to PM, well, what would your interpretation be? That SRS is sending us those ratings, but rather we're requesting those ratings. I have to request it, which means that request originated with me. So typically what I'll show is a hand or some symbol that says, I'm stopping and waiting for information to come back to me. And that information happens to be ratings. So I'm talking to SRS, but it's giving me back information. Trades do go back and forth between TM and ATP. So you might say, but Mark, there's a good example of a bidirectional arrow. No, I disagree with you because it doesn't have the right information. What's going back and forth? Oh, so original trades are going to ATP and then adjusted trades are coming back to PM. This makes sense. Now with data, what I typically do is this. If it's read-write, if I'm writing to the data, but also if I write, I implicitly read, I'll put an arrow to that database. But if it's read-only, I'll put the arrow away from that. Notice RT and CE here. The arrow's pointing away from the data, which gives me indication to know that's read-only. That's pretty important because if I'm only doing reads, that gives me some alternatives and options to treat that data. Okay, so typically one of the standards we typically do have is dotted lines for async, solid for sync. And so consequently here, you'll notice that RKS asynchronously sends trades to PM. ATP adjusts trades asynchronously and get sent back to PM. All right. Shapes. Can anybody here tell me why RT and CE are different shapes than the others? I can, because they wouldn't fit on the page. I had to squish them up. And that's the real reason why. Yes, be consistent in your shapes. Have a reason, a distinguishing factor, because I'm sure all of you said, I can't wait to see what RT and CE are because they're a different shape. That must be a different kind of service or something. No, it's just that I got bored and wanted to squish things up a lot. So be consistent in your shapes. Also, I'm assuming at this point everybody knows this architecture now, right? RKS, PM, ATP. Nope, we still have no idea what you're talking about. So we try to avoid acronyms unless it is a common term. I'm not going to say, oh, this connection uses representational state transfer. No, we all know REST. Maybe the entire company knows RKS because that's what we call it. That's fine, but you guys don't. You have no idea who's going to read your architecture diagram in your story. So now we use the words. Record-keeping systems sends transactions to the portfolio manager. The portfolio manager then sends those original trades over to the advanced trading platform, ATP. It then sends trades to our rebalancing tool and our crossing engine, which then modifies those trades and sends those adjusted trades back to the portfolio manager. And the portfolio manager gets its ratings for all of our bonds through the stock rating system. Isn't that cool? Yeah, acronyms can kill your architecture diagram. Well, we're almost done here because we've got color here, orange. Scott did a wonderful job a couple days ago, I think it was actually Monday, in his talk on accessibility and kind of color deficiency. If you are going to use color, I highly recommend blue because 90% of all color deficiency people can see blue and discern shades of blue. So now I've really most people can read this. You wonder why all of my books in print or on PDF, all the images are blue. It's for this reason. Yeah, most publishers use blue for this. Okay, and finally, what's the most important thing here that I want your eyes to focus on? Looks like the portfolio manager, doesn't it? No, you know what it is? It's the advanced trading platform. That's what this whole architecture is all about. Yet what did I do? I shoved it in the upper right-hand corner, away from everything. Orientation of your diagrams matters a lot. That's where your eyes go, everybody. It doesn't go to the corners, it goes in the middle. I'm going to reorient this. Not one thing changed. And now you can see exactly what I want you to focus on. ATP, the Advanced Trading Platform. And the last thing, what is that hand all about? And why do you have arrows going from the database? I mean, does the database call the rebalancing tool? We don't have standards like real architects do. So we need to provide a key. And so that's the very last thing on here. Now we have a key to describe all of these nuances that we all get, but our VP of Operations has no idea. Okay, so do you see with these little tips, we went from that architecture diagram that you never even was like, I don't know what this is, over to something we can actually read and probably start implementing. That's awesome stuff. All right, so I want to close by showing you two other pieces of this resolution. The first is something called representational consistency. When we move from view to view, it's important that we don't lose our reader. If I'm reading a story and all of a sudden I turn the page and there's a new setting and characters, I'm like, where are we? What is going on here? All right, I'll read a little bit more, but now I'm getting bored and I put the book down. Yeah, because I switched the context. Representational consistency is this. Now, here's my architecture right here of the student testing system, assign in a test taker and an auto grader. But I'm going to drill down, and what I really want to show you are the inner workings between the artifacts for our microservices. Can you stop for a minute, Mark? Sure. What is this thing? Where are we? Because you just showed us this, and now you're here? I am confused in this story. Representational consistency is ensuring that the reader of your architecture, your story, knows exactly where you are at any given time. This is representational consistency. The C4 model does a fantastic job of this. One of my favorite aspects of the C4 model by Simon Brown is its view of representational consistency. As we drill down from each of the C's, we can actually have a roadmap of exactly where we're at. And we've been talking a lot, or I shouldn't say we have not been talking a lot, I've been talking a lot about this new concept called architecture as code, leveraging architecture definition language, ADLs, to be able to not only describe my architecture, but also be able to generate executable source code to enforce that architecture. If you haven't seen either my keynote or my sessions on this, you can get those on the recordings when they come out. But the point is now we can see in our resolution, we have architecture diagrams that shows us the how. We have ADRs that shows us the why. And now we have ADLs that describe our architecture, which then shows us our structure and our capabilities and allows us to enforce that. That's a resolution. So that's Act 3. This, everyone, is a way to tell a very compelling story. Act 1 setup, our business context, environment, all that confrontation, all those challenges, trade-offs, and finally the resolution, all of our diagrams, ADRs, and ADLs. This is a really compelling story. It's actually one I kind of want to read. Anyways, fantastic. Thank you so much, everyone.